Good morning, everybody. My name is John Lindberg, in case you don't know me. I've been with HYPACK for quite a number of years, about 22 years or so. I'm going to, well, first of all, the other two rooms, just in case you're not sure where you want to be, Jerry's doing sensor theory in the main room, where the initial presentations were, the welcome stuff, and then Joseph Adamski's in the other room doing introduction to surveying and HYPACK. What I'm going to do in here is Geodesy and RTK. Basically three objectives here. One is regarding geodesy, and this basically has to do with how I'm far from a geodesy expert, but I can explain how it works in HYPACK and everything. So I'll attempt to go through some real basics of geodesy as far as my knowledge of it, run through the geodetic parameters program. The second would be running through the RTK options and how that works in terms of HYPACK. The third objection is we're going from 10:30 to 12 o'clock, so I want to have everybody out of here like 10 of 12, so you guys are first in line for lunch. So we'll see how we do. You know, if I start talking over that, start throwing pencils or something up here, and I'll see if I can get you out the door. So, okay. So understanding geodesy. You know, typically, you know, the way it's worked in HYPACK for so many years is that, you know, you're getting a GPS signal. It's typically in a WGS84 latitude, longitude output. You know, there are a lot of variations, ITRF, and you can actually set GPS's output, Clark 1866 or international ellipsoids and everything. But we're making the assumption in HYPACK that the GPS is set up for WGS84 output. Okay, so basically the way it works in a project in HYPACK where you're working in WGS84 or NAD83. This WGS84 is typically your UTM grids. Is that we take that latitude longitude from the GPS, do a grid conversion, and then project everything in XY. Okay. When you're working outside of that, and I'll explain how to set it up in HYPACK, is that anytime you're not in WGS84, you know, the GPS is still set up for WGS84. You need to do a datum transformation where we project to the local latitude, longitude, grid conversion, and then we have the XY projection. So the basics of, you know, some of the stuff, the geodesy, the ellipsoids. Ellipsoid is a mathematical shape, approximates a geoidal surface, and your position is defined by latitude, longitude, and ellipsoid height. Okay? And these can most likely change based on the shape of the ellipsoid. So there's all kinds of different ellipsoids, you know, the WGS84, international, quite a few other ones. Then when you take an ellipsoid, you know, to complicate things even more so, is that you can shift this ellipsoid based on the location, you know, where you're located, and basically when you shift that ellipsoid, you're going to have a different datum. Okay. And here are just some of the examples: NAD27, NAD83, UK National Grid, the Holland Grid, Hong Kong, and so on. Okay. And then in order to shift to this additional ellipsoid or datum, we need to do a datum transformation. So again, the latitude, longitude, and ellipsoid height varies depending on the datum being used. And you know, again, this process is just called datum transformation. And we'll run through a couple examples of that. Okay. So a rule of thumb with datum transformations that you're surveying in WGS84 on a WGS84 ellipsoid, you don't have to do any type of datum transformation. If you're working in anything other, international or one of the other ones that we've mentioned, then there's a datum transformation required. We got the right one here? Oh yeah, you need to do a datum transformation. Yeah, and there's quite a few different ways. You can either determine your datum transformation parameters. We have a few programs that allow you to do that under the utilities menu. You can use a datum shift model, like for the US, there's the US for continental US LLS file that you can load up, and it'll do the datum transformation automatically. UK has their own datum shift files. A few other countries, I think France has one also. The UK's had changed a couple of years ago. Or you can actually manually enter your, you do a 3 or 7 parameter shift. And I'll show you a couple examples there. Okay, here's the window. So when you're setting up your geodesy, I'll show you real quick. Let me go into geodetic parameters. So we're talking about, here's the little geodetic parameters icon, or you can go under preparation, click on geodetic parameters. We did a slight change to this program. Oops, what am I doing here? Get rid of that window. This used to be a separate, are you seeing it over here? No, you're not seeing it. See if I can drag it. Hey, look at that, there it is. Okay. This used to be a separate executable program. It's been built into the main HYPACK shell now, and it's just to simplify things and keep the things working a little bit more smoother. But basically, what happens is that when I'm talking about the ellipsoid, you'll notice if I choose a grid like NAT 83 over here, it defines the ellipsoid and other information right up here. And basically, these items are grayed out. You're really not going to change those. Usually when you see that grayed out, I guess it's grayed out. Make sure. Yeah, you can't click in there. Just meaning that there's no datum transformation needed. If I'm working in something like NAT 27, for example, you'll see it opens up, let me close out of here. By default, it's loading up the Con US LLS. That's something that was done recently. But if I have a specific set of datum transformation parameters, either 3 or 7 parameter, I would just put in the 3 values for the delta X, Y, and Z, or the 7 parameters for all these. So I can hit the X here, get rid of that. You'll see that it opens up all these parameters. Places like over in the UK, you've got the UK National Grid. Scroll down. Okay, so in this case, I would go to the datum shift file. They have OSTN 15 is the UK one, and you can load that up. Over there in Bristol, they don't use the LLS file. They have their own local parameters, so they'll just ignore that by clicking on this and enter a 7 parameter shift, and it's basically more localized for that area. Okay. So again, as it's grayed out, it's not necessary to do a datum shift. When it's all open, you can either do the 3 parameter shift like we're seeing here. You've got the delta XYZ values, or the 7 parameter where they're all changed. And then when you choose the national transformation, when you hit the browse button, load up the LLS file, you'll see it lists the LLS name, and everything else here is grayed out. All right, let's see what we got. And then projections is basically a 2D representation of an ellipsoid. So you have the rounded ellipsoidal surface that when you try to flatten it out in 2D, it's basically going to distort the different points here. So a good projection will basically minimize that distortion of projection points. And these are just some of the different types of projections. The Mercator, basically taking a piece of paper and wrapping it around a cylinder like that. The least amount of distortion is right along that middle part. Transverse Mercator just kind of rotates it this way instead of that way. Oblique Mercator, I believe you have some rotational transformation values. And then the Lindberg conformal is basically a kind of a cone shape that fits over the ellipsoid, and the least amount of distortion is where they actually meet along that, where the cone and the ellipsoid actually meet. And then the conformal conic 2 basically has the 2 intersection points along between the cone and the ellipsoid. So again, going back to the project geodesy. Every project, if you're familiar with HYPACK, you know that every project can have totally different geodetic parameters. And like on my computer, I probably have thousands of customer projects and everything, and they all have different types of geodetic parameters depending on, you look at the different state planes here in the U.S. There's how many UTM zones, the north, south, and then all the international ones. And we're constantly building in new geodetic parameters for different areas. I'm understanding that in 2022, they're coming out with a new version of, I think they're switching from U.S. survey foot to international foot throughout the U.S. So that's going to make some changes. So we'll be adding that to HYPACK as it comes along. Recently, Australia came out with Geoid 2020, which we added at the beginning of the year for HYPACK also. Any Australian customers here? No? Okay. And as you set your geodesy, when you create a new project or copy a project, it'll just copy those geodetic parameters to the new projects. Okay. So again, like I showed before, you click on the world icon there, or the globe icon, or go under preparation and click on geodetic parameters. So yeah, just some examples here in the UTM Grid. As I mentioned before, is that you hit the drop-down menu for the grid. I gotta figure out why I'm not mirroring the image here. Figure that out a little bit. Yeah, so I got my geodesy, I've got my choice of UTM north or south, and then I have all the different zones listed here. Okay. And by default, it defaults to meters, but if you're working UTM, I think there's a couple districts that actually use UTM and US survey foot. So you could just hit change the distance unit to US survey foot. Then you have the option to change the same as horizontal or shift it. A couple people do that for some reason. They'll set their depth unit to meters, but distance unit, US survey foot, to me that just adds a lot more complication. I would just suggest working in the same all the time. We have a checkbox here for those that insisting on working in elevation mode where it's positive going up, which adds even further complication to HYPACK when you're working in elevation mode. A lot of times I caution doing that because you're working in elevation mode, you start editing data and inverting data. It gets pretty confusing as to whether you're adding or subtracting a tide correction and so on, or water level correction. So it gets pretty complicated. I'll leave this part out for a second here. Just going to kind of go over the top part until we get into the RTK. And you'll see, because we're working in, well actually WGC, UTM, you'll see that you can hit the drop down and choose a different ellipsoid. Okay, so we're set at WGC 84. As I go to like Krasovsky, wherever the heck that is, I'll choose that one, and I'm assuming Russia, I don't know. But then it opens up the parameters here that I can enter the areas. I think there's a couple, I think one of the Australian ones has, some of them actually have preset. Yeah, here we go. Australia NG 1984 actually has preset 7 parameter shifts. So there's a few different predefined grids in here that have that. Okay. And then you'll see that this is also grayed out depending on the grid that I choose here too. So you can't change these. If there is a grid that's not listed in HYPACK, you can actually go here and drag this all the way down and choose user defined, and you'll see it opens up everything. So you're working in some other place, or somebody comes up with a new grid that's that we're not supporting yet. Usually you find the information on a website somewhere, some kind of papers or whatever. So you choose user defined. You can hit the now you can just go in here and change whatever ellipsoid that you might want to be using. Yeah, Everest, that'd be kind of cool. And you'll see that it opens up a few of these things. You could get, if for some reason there's an ellipsoid that's not defined, you could go in and I believe there's an option here. Oh yeah, user defined right at the top. And you can go in here and change these values. And same here, goes with projection too. So we have a bunch of different ones listed here. We can put in your other information. Okay. Cancel on that. I want to mess up those settings. Okay, did that one. Okay. talked about that before. Yeah, you choose a NAD 27 grid. You'll see it'll when you choose that, it opens up these where you can actually type in the values. Years ago, I remember we had to actually we had a tool, a little button that said use Corcon, where you just type in your approximate latitude, longitude, and it would calculate your local delta XYZ datum transformation. And then we added a datum shift about, I don't know, 15 years ago. As you load up the file, and it just does it right on the fly. Talked about the UK grid. See, it's the area ellipsoid. So again, like I said, anytime it opens up those options there, you're pretty much required to do a datum transformation. Okay. So again, if I went into those user-defined parameters as I mentioned earlier, I go in here, change all these different values, get the right values. I could go under the Tools drop-down menu, click on Save Custom Grid, give it a name, and then it's going to give me the item listed right in with my geodetic parameters. What it does, it creates this .cgeo file that gets stored in our datum folder, and it's a little file that the program automatically reads, and you can load up your parameters that way. Or if you set it up in the office, you can send it to your survey guys. They can throw that right into your into the HYPACK datum folder, and then load that right up for their geodetic parameters. Okay. Local grid. This is an option we've added a number of years ago for you're working on a basically a local, like a company grid or something, where you have you're taking some point where this point right over here might be whatever latitude, longitude in WGS 84, and you're calculating you're getting a say Florida State Plane XY Z value over here. Okay, but the company is defining that, say, as 10,000 for easting and northing. Okay, so, a lot of times they'll do stuff like that. So we give the option in HYPACK in order for you to be able to do a transformation to this, off kind of grid. Okay, so basically what you need to do is you need 2 points for that area. So you have to have your some sort of grid that's set up in HYPACK, UTM, state plane, or so on. You have the 2 points there, and then you have to know what those points are in your local grid. Okay. So what you do is that you initially go, let me bring that up here. All right, so let's say that was, I don't know, it was UTM something, zone 17, let's just say. Those XY values and US survey. Okay, so once I set all that up, you'll see all these values change, okay, to the way I want. So what I need to do in order to get the local grid adjustment working is I go to the drop-down menu, again, for the predefined grids, go user defined. Now you'll see it opens up this little checkbox here for the local grid adjustment. Check that box, click on local grid, and then I enter those parameters that we had before. We have the world coordinates, UTM or your NAD 83 or whatever, what have you, for point 1, the easting and northing, for point 2, and then we have our company coordinates or local coordinates for point 1, point 2. You click on the calculate button, and basically you should see point 1 here listed right here, and it's going to create your translation values, the 10,000 we saw before on the screen. And we're going to have the rotation and scale values. So all that stuff, once you do that, you click OK, and then your local grid is all set. And again, you can save those parameters as that CGO file if you want, and then you're good to go. So yeah, here's an example of just entering these values. We've got our world coordinates here for point 1, point 2, local point 1, point 2. We've got our values here, the translation and rotation and scale. You have a couple other options too. Occasionally you get into a position, something where you need to reverse the direction of X or Y axis too. So we try to accommodate everything. And then just an example of the results in our grid conversion program. You go into Utilities, Geodesy, go to grid conversion. You enter a lat long for your area, click on Convert, and you should see the converted X and Y coordinates. Okay. few years ago, we've added the option for the time variable transformations. I believe working on a lot of the systems, I think some of the satellite-based systems and POSPAC, I think you can do some of the stuff where you're working in ITRF. So you could go set up your basic grid here, but what you would do is go into the tools, go to time variable transformations, choose your ITRF epoch here, your target system you're working in, and then the year. So you have a decimal here, so you put approximate, you're working in 2020, you might leave, like for January, just leave it set to 0.0. Maybe June, July, you go 0.5, 0.6, something like that. And then it's going in. Again, it's a time variable datum transformation, and it's going to basically give you a 7-parameter shift based on, your ellipsoid and the time shift. Okay. Any questions on that? Okay. 10:52. All right, let's see what we get into as far as RTK now. Okay. A few years ago, we built this all into the Geodesy. Like I said before, I kind of covered up that section of Geodesy. I'm just showing that bottom part now. And we decided to build in all the different methods or possibilities right into the geodetic parameters program. I don't know, sometimes I think it's a little bit easier, sometimes it looks a lot more complicated than what it is, but we try to, as you choose an option here, and I'll try to explain all the different options here, you click on one, and it's going to give you the available options on what you need to fill in order to get the RTK. So typically, again, in HYPACK, you're making the assumption that you're working in RTK. The GPS is in WGS84. You're outputting ellipsoid, antenna height above ellipsoid. Okay, and then we're doing all the other conversions. There's a lot of support calls where they might enter. I guess you have the ability in a lot of GPSs to output a local height. If that's the case, you're going to load a geoid model or KDD file and so on. So there's a lot of stuff like that too. And one cool thing that we've done in HYPACK over the past few years is be able to recalculate RTK in position based on your geodesy settings. So if you go out in the field and you collect a whole bunch of data, realize you used a Geoid 2012, they have the new Geoid model out. Was it 2018? Which I think we actually have available for download for the CON-US anyway. So you can set up your geodesy with the new geodetic parameters. Go check off the box during your editing, and click on the box that says recalculate RTK, and it'll recalculate your water level heights. And was there anything else I was mentioning about that? I had been going. There was a question last year. And I've been trying to run through the slides because they've been a little bit sloppy. Where is it K minus N or N minus K? And I was talking to one of the programmers, and I've been looking and just verifying and going through all the presentations. It's actually K minus N. And the reason he explained to me is that when we were doing this stuff, the RTK, there was like maybe a world geoid model. There were a couple very low level what do you call it, NGS models too that really weren't worth a damn. So in the earlier days, we were more confident in a KTD file where somebody's actually going out and surveying that local area, and just by default we called it N minus K. All right. So, but the actual what do you call it, for the formulas should be K minus N. So hopefully that clears things up, or whoever asked that question last year. Okay. There's a certain number of drivers that that will work as far as RTK. The most common are these right here, the GPS DLL. So that works with in differential or RTK or standalone if you want. The F180 DLL, this is not DLL here, which works with all the Coda Octopus systems. Novotel DLL works with most of their RTKs. I think works with a span system and everything. The fins is the XC/X blue items, so that works with the Atlas systems, the what do you call them, IMU systems. Of course, the Planix, the POSM V works with all theirs. SPG works with the Ellipse, the Equinox, and all the other systems, and the Kongsberg CPAP uses the CPAP key. Okay. And typically, it's been set up in HYPACK where the only time you're actually going to get RTK water levels is when you're in RTK fixed mode. Okay, there's been a source of contention about that for many years, because a lot of people are saying, you collect the raw data. Why don't we collect everything, and then I want to be able to filter that out after the fact? So there are ways of getting around it, and as we're constantly updating device drivers and things like that. As we go along, more features. Sometimes that's good, sometimes that's bad, as most of you guys know and everything. We got everything there. Okay, loads kinematic. Oh yeah. All these different drivers work with again RTK. They'll if you load up a KDD file or Geoid model, all that stuff is used to determine the real-time water level. KDD file again is specified. We'll get into some of that stuff in the geodetic parameters. Important note here, remember tide corrections in HYPACK are negative if the water line is above chart datum. So again, it's a tide correction, it's not a tide value. So it's hard for people to get that ingrained in their heads. But just the way it's been in HYPACK for quite a number of years, I don't know if we're going to change that because it might cause more issues, but who knows, maybe if we get general consensus of making the changes, we will. All these options, all these device drivers have a tide function in hardware. And I'll show you real quick, just in case you don't know. I click on the shell and I click on the hardware programmer, preparation hardware, and of course it's coming up on the wrong screen. I got my GPS DLL loaded. You'll see down below here where the functions are, there's the little checkbox for tide. Okay, so that has to be checked in order to calculate the RTK tides, and then we have to set those functions up properly in Geodesy. I'll get to that in a little bit. Now, each device driver has a different setup depending on what you're using. So you'll see the by default minimum status for RTK tides. There's a little slider here. Okay, so if you want to collect, you don't care, you want to collect all the RTK information, you can drop the slider down to any status. But most people only want to have the fixed RTK, and then the HYPACK will just interpolate between the last couple of good RTK points. Okay. And if this is all dependent with the GPS, is that the standard, the NEMA 3.0 standard, where there's a code in the GGA, the GGA string, a numeric code, which in this example, RTK fix is a code value of number 4. The older GPSs and the GGK strings, I think, go by the NEMA 2.1 standard, where there is no differentiation between, it's just RTK. So fix and float RTK are just by default 3. And then you get, if they still have them, I know some of Trimble used to have something called location GPS, where it was technically like a fixed RTK, but it was maybe like a 2 centimeter accuracy or something. And it was like an 11 or something, totally bizarre. So we gave the option in here to go under custom. And then you just go in here and put whatever that value is for your fixed RTK. So these are the different variables available when you're calculating RTK. You've got your antenna height here above your reference point. You got your actual tide value, little asterisks here, meaning that that's a positive tide, but in HYPACK we invert it. Antenna height above your ellipsoid, the actual depth surface draft also. Your chart sounding would be your final result. You have your K value, your K minus N, your N value, so on. here we go. That's basically what I said over there. All right. Basically the same stuff there. Yeah, so that little T with the is the HYPACK height correction. It's the inverted value from the height. All right, so now we get into the formulas. This makes more sense. Okay, so basically the with a KTD file, for example, we're concerned about the separation between chart datum and ellipsoid, the ellipsoid reference, okay? And that would be the K minus N. And then the height of a WC84 above the water line is minus antenna height minus, antenna height, ellipsoid height minus depth. Okay, so the HYPACK height correction, you'll see, did I forget? I don't think I turned that one around. But basically, the only difference here is because this is the N minus K is inverted, is because we're basically inverting for a tide correction, not the tide value. But internally, everything is done with this method in order to get that tide value, with a positive tide value, but we have to invert it as a tide correction. Okay. I don't think So here's just a number showing how the math works. I won't get too much into it, but basically, as you got your height above data, and you got your height above water line here, and just doing the math and coming up with the values. Okay. Ultimately, we want that chart sounding based on the RTK values. So now we get into the actual options in Geodesy and the geodetic parameters. And you'll see if you're just working, you're not too concerned about RTK tides, you just go to the option here, not using RTK tide, and it won't do any of the calculations. You can use it if you're using a tide gauge, or you're manually entering a value, or like a lake level or something like that. You can check that box, and then just enter a tide value right in the survey program. All right, the K minus N from KTD file. KTD file, again, is just the separation between chart datum and ellipsoid. So there is no differentiation between the N value, which is, I think, the geoid height, and the K value, which is ellipsoid height. Those are typically combined. There's usually two separate values inside for example, inside a GGA string, where you have, and those usually get added together too. So it's another variable. So that's if you're using a KTD file. I'll show you how to set that up in a little bit. N minus geoid model. That's where you load up one of these geoid models, especially in the US, like we have the Geoid 2018, 2012, and so on. And you also have, you might have that geoid model, which takes you down to, was it, again, not even thinking now. It takes you down to, not mean low. Ultimately we want to get down to mean low water. So this will take you down to the. It's not top of my head for some reason. I can't think of what it is. Anybody know what I'm talking about? Well, anyway, it's that one surface, and typically when you're working in a local area or so, there's your local data, mean low water, mean low water, and so on. There is a few tenths difference or so. If it's a small area, you could just put in a value like a orthometric height correction, or height of geoid above datum, or load up create a KTD file. Again, we'll talk about how that goes. We've added this function a few years ago where we could load up the VDatum files. You can download those from NOAA, and it still requires you to load up the latest geoid model in order to derive and get whatever data you're using, whether it's mean sea level, mean low water, mean high water, mean low water. Gives you all those options. We've recently updated the VDatum zones too, so it's a bit of a complicated process right now. You can download the latest ones from the NOAA website, and they'll be recognized in 2020. We also have it's called a GeoPAR database file. which you can copy into 2019 if you need to use the latest NOAA VDatum files. Okay, and then probably the most common is the N from geoid model, K from user value, where you're manually correcting down to your local value. And if you're not using any of that and you just determine you've got your own separation for an area, you can check this option and do the K minus N from user value. We got it here.
I have a question.
Sure.
Applying the geoid model in HYPACK, is that assuming that geoid is also applied in your GPS, or that it's not?
That is not applied in the GPS, yeah.
Step up maybe.
Yeah. And I know some GPS actually output the correction, and some don't. So it's, we usually recommend just turn it off in the GPS. If you do, then you could probably set K minus N from user value, not put a value in, and it'll just use the one that's applied in the GPS.
Right.
So a lot of little weird tricks that you can do in there. Okay. So again, this is with the RTK ties with the K minus N value from the KTD file. So, and basically all a KTD file is a grid. Let me see now. With separation values. Okay. So again, yeah, here's the K minus N that's in the KTD file. So separation between chart data and your ellipsoid. Okay. So normally use of separation between layers is not a constant, and you're not using VDatum. KTD file contains K minus N values, height of ellipsoid above chart datum. Most of the time used if no geoid file is in use. Okay, and then it's just the K values. The N would be basically the geoid value, and then K would be the value you're deriving from the KTD file. Okay, so in order to the way they did this for a lot of the districts, I believe it was Brian Shannon years ago that worked with a lot of the core districts and developed these, derived these KTD files where they would set up a GPS somewhere along an area. They know the height of the GPS at a known point. They know the water line, and they basically calculate that reference ellipsoid, the chart datum versus ellipsoid value. So they come up with a bunch of these values in different areas, and then you go back in here and you just set up, you just create a grid of all those separation values. So once you do that, you could go into our KTD tide editor, set up your min-max X and Y values. Everything, geoid models typically a lat long format, but the KTD file is in your local format. And then you just enter all your separation values in a grid format. We have an easy way of also creating a KTD file in tin model, where you just load up, save your separation file in an XYZ format, and you have a bunch of random points. You want to create a nice grid, load it up in a tin model, have it generate a 3D model, and then it'll export a nice gridded KTD file for you. And in the main shell, you can display the KTD file values, so you can get a rough idea, especially if you're comparing the KTD versus your VDatum values. I'll explain that in a little bit. So you can export your KTD file in the form of an XYZ file, draw your KTD points, and get a rough idea what the separation is in that area. So you can manually calculate your RTK values just to verify that you're in the right direction.
I have a quick question for you. Have you ever had people calling in and get a complaint of when I'm on rivers in the Great Lakes that change quite often? I check in a lot of times to the gauge boards or different monuments that are along the rivers. Mm-hmm. And I've never been able to build my confidence with setting it to the RTK tide, because every time I check into them, if I check in as often as I would like, it seems like there's quite a difference. There's 1/10 to 2/10, which would be quite significant when you start coming up with your volumes.
So you're seeing that compared to the local gauge or something like that, or
well,
seeing
if I just take and run an RTK and go over to these gauge boards or these monuments that are already set up along the river, they don't check in with the elevation, even though I'm pulling RTK values, there would be quite a significant amount to the point where I'm scared to use RTK ties for
Right.
fear that if that's what's coming into HYPACK, I'll be that distance off versus just using a gauge.
Yeah. Are you using using a heat sensor and everything too, or
No,
so
it's
just a
flat
regular?
along there. So most of the time when I make my check, I'm checking against a static location. I can pull right alongside and
Yeah,
set it
yeah.
down, either a chisel mark or something like that. It's along the rivers.
Are you using a geoid model or any type of, well, I don't think we have the V-datum zones for that area, but there still is most likely a shift between the geoid model and the local datum too. So you're gonna have to determine that, or most of that stuff is probably published anyhow, so that could very well be what's going on.
Well, I don't know what that is then, because that's I guess my biggest fear is I would love to be able to go so in the event that there's a little bit of wave action where I can just go into the RTK tie.
Yeah.
Versus using gauges.
Mhm.
But again, just the confidence isn't there because food checking will allow them to line with some gauges on. And I didn't know if that was already a question that somebody already asked me.
No,
There's an answer or solution to it.
Yeah, yeah, that's a tough one because I mean, we know mathematics-wise, it all works out properly. Usually, we'll get data sent to us, and you go through all the math, and everything comes to what it's supposed to be. Whether it's matching the gauge, I mean, is the gauge probably set up too? So there's a lot of variables there. Fortunately, in HYPACK 2, you can do the recalculate if you realize, well, maybe there is a shift or something that I need to enter or something, and I can run the recalculate RTK if I have to in that process. So it doesn't hurt to collect all the data anyway, and you can always replace that with your time gauge information after the fact too. So and just do some kind of comparisons, but talk to any support people later on too if you want, or give us a call, and you can probably try to figure out what's going on, or look into it. Just bang out the local area, your datum and all that kind of stuff. So, let's see. All right, so we got the KTD file. Okay. Yeah, so in order to set that up in the Geodesy program, pretty straightforward. I think, yeah, this is the Savannah area here. So if I went to Geodesy, and I've got it set up, wait, no, let me go here. So if I go to, if I want to use a KTD file, once I create that file, I can click on N from, this one here, K-N from KTD file. I can hit browse, look for that KTD file, click OK. So now when I actually run survey, I'm getting RTK ties. Got my variables, my antenna height, my ellipsoid height, antenna above ellipsoid, antenna height above water, and so on. It's going to factor in the KTD file. This is the separations of that KTD file in order to come up with our RTK tides. But pretty straightforward. And if I zoom out here, oh, look at that window open. Of course, you're not looking at what I'm looking at, so I need to drag this window over here. There we go. And let me hit zoom extents, but you'll see if I look at the KTD file over here, and I just double clicked on it, and it brings it up in the KTD editor with the min-max X and Y values, all the separation values. Okay. So a good way to get an idea of what that separation should be. And any of the Savannah guys in here? But they've been using this for quite a long time. They have one for the Brunswick area. I think Jacksonville has one. Seattle, I believe, used to have one. Still pretty valid data. So. Okay. And then, like I mentioned before, if you do have, you load up a geoid model, but your area, the data that separation is different. You can load up the V-datum files. Okay, so go back in there. Here we go. And let's see what happens when I open up Geodesy, if it opens up on the right screen. No, of course not. Oh, it did. All right. Okay. So if I go, if I want to use the VDatum, let me just show you really quick. Let me open up Explorer here. No, the other screen. If I go into my C HYPACK 2020 datum, there's this VDatum folder, and I've got all the zones. You can download these from our website as an install, but it's just as easy to go to the NOAA website, download the zip file, and copy all the. There's a VDatum folder. You just copy it into this datum folder, and then HYPACK will recognize the zones that are at least the ones that have been updated as of I think October or November this past year. So if I go N from Geoid model, K from VDatum, I'm loading up, in this example, the Con US, I'm working in Georgia East. I could go hit the drop down, and I'm not sure which VDatum zone is. Again, you could download the entire data set, or you can just download your local area. Let's just choose the Georgia, South Carolina, North Carolina. Okay. And then you'll see, here's the, right over here. Oh, that's weird. It should list all the different chart datums. I gotta find out because I heard that there might have been an error in the version 4.1. But I got a little trick around because I can load up the geodetic parameters program. The old one. Let's go to VDatum. Doesn't matter which one I choose. Yeah, here we go. Okay, so there's a little bit of a bug in there. Fix. But yeah, you have the different chart data available. So if you want to use mean local water, I believe this matches pretty closely to the KDD file that they use all the time. So essentially, we'll get that fixed before we get the 2020 released. Any day now. So most likely this would be set to 0, but if you still need to do some sort of a fudge factor, maybe there's a slight variance that the VDatum's not accounting for, you can put an orthometric height correction, and it's going to shift it even more so. So there's a lot of different ways of adjusting and getting the proper RTK heights. Okay, so we've got our N values taking care of the Con US 2018, the Geoid model is taking care of the N value. The K value is coming from the VDatum zone.
The 12's pretty much, G2012's pretty much, that's not lovely. You realize, man, never mind.
Yeah,
Anyway,
I was even right here.
So the 12s are pretty much the G2012 kind of continental. It's not, you don't even use it anymore, just stay with 18. Is the new update?
Yeah, they're usually updated, more accurate, theoretically more accurate anyway, so. A couple of core districts had requested, they knew that was out on the NGS site, so we had to just convert it to our format, GEO file, and then add it to the build. So it's in the 2020 build, and it's also available for download from our website. Okay. All right, what's next? Okay. Yeah, K minus N from the user value is that other option where you can just go in. It's not coming up here. There it is. Okay, go back in the. Yeah, K minus N is if I'm not using any Geoid model or KDD file, I'm working in a small area, might be working on a lake or something, there's a specific water level that I want to calculate to. Basically, a certain level that they have marked somewhere with a gauge or whatever. I just set up my RTK antenna. I've got my ellipsoid height that I'm reading off the GPS. Got my water level. I take that value. It's basically my separation value. Enter it right in here. Click OK, and then that's your separation value being used. Okay. So I think that's the basics of all these here. You have again. The the K minus N, that's just when you're using a KTD file. Geoid model, K from KTD file, where the KTD file is taking care of that K value. And from Geoid model, K from VDatum, where VDatum is taking care of the K value. And then if you're just using a Geoid model, you can throw in, again, you have a couple options here. You can either, if you enter it as the orthometric height correction, it adds that orthometric height value to the N calculation. If I add it to here, it adds it to the K value. So probably the most, and I'll probably want to modify this and put a note as to what's considered the N value, which one is the K value, because they act differently. I believe the orthometric height correction does not get inverted, so it's basically like a fudge factor value. Okay. All right. Let's see what else we have here. Okay. We put a neat tool in here also, this export VDatum to XYZ. So you want to set up your VDatum. Question?
Can you explain why I would use a KTD file versus a Geoid with a fudge factor?
Well, the KTD files, I mean, we're probably earlier in the days when before the Geoid models were pretty consistent and pretty solid. So some of the areas were set up with a KDD file, and they, I mean, there was a lot of thought behind them. Whereas the Geoid models are obviously world models or area models and everything. So there could be variances. There might be areas that weren't quite calculated properly and stuff. So you might need that fudge factor or whatever.
I can use the fudge factor whether I'm using a Geoid with a user value or a Geoid with a KTD.
Yeah, because the Geoid model just takes you down to that Geoid or whatever. You still have to get to the chart data, you know what I mean? So you can either use a VDatum, a KTD file, or just whatever the value is. You might, from the Geoid model to the chart data might be 3 or 4 feet or something like that in that area, and it might change, 5 miles down the river or something like that, or whatever. So you might, if it's changing and you're surveying all that area, you might want to create a KTD file. But if you're working in a small area, you just put in that one fudge factor value right there, and it's going to bring it right down to your chart data.
Okay, so if I'm working in an area where the fudge factor would be variable, would be worthwhile to create a KTD file?
Yes, exactly. Yeah, that's where you would have to do it. Yeah, because most likely it's going to change as you move further away from that one point. Okay, so the export VDatum, I could take those separation values that are being generated by that we're using in VDatum and just export those to XYZ file, so I can see what that shift is created by the VDatum, and just export the XYZ, draw them in the shell, and get an idea of what those values should be. There's also a checkbox in here because some of these VDatum zones are pretty big, and when you export a XYZ file, it could be 50, 100 gigs, 100 megs, I should say, not gigs, but for the different zones. But you might want to just kind of centralize a small area, create a border file in HYPACK, and just export those separation values in that area.
Hey, John?
Yeah.
I don't want to go backwards, there's just a question. As far as when you're in Geodesy and the zones come up, is there a map that you can look at with the zones? And actually, is there, so you say, oh, say I'm in Savannah, then I go up to North Georgia, for instance, which the elevation changes.
Yeah, on the NOAA side, it's pretty good. If you just Google, VDatum and go to their download site, I think they actually have an interactive map. So you can click on an area and it's just going to tell you which zone.
There's always the outside chance we have to go do a survey there or wherever. So.
And each, what's cool too is their folders, the VDatum folders have a KML file, I think, in there with the border of that zone. So you can just double click on that and pop up in Google Earth and see if it covers your area.
Quick side note on that. Are you referring to the UTM zones or like state line coordinates?
Not the one underneath it, the actual zones where you can pick Georgia East or, yeah.
Okay, so all this geodesy stuff is getting logged in our HYPACK raw files. So when you look at, and this comes in really good for quality QC purposes or troubleshooting purposes. Somebody has trouble with it, we'll ask them to send a raw, log a raw file, and we can see exactly what's going on inside there. Normally in the header, we have our geodesy information up here. If you did a datum transformation, those values you're going to have 7 parameters listed here, or you're just going to have 3 parameters if you're just doing a 3 parameter shift. If you're using a geoid model, we've got the value here with the orthometric height correction that might have been entered in, the little fudge factor. I doctored this up just to make it look good. Horizontal and vertical units. This is just if there was a 1 in here, that means that you're working in meters. The VDatum zone would be listed up here. The surface, in this case, it's mean low water. The devices here, okay, time and date, the local time offset. We have our GPS DLL being used over here. Whatever the name was given to it, the version of that, because if there was a bug in a certain device driver, we could tell you 1705 had a problem or something, wasn't taking into account a KDD file or something, and just tell you how to fix it. We have our offsets from the device driver. If we had a KTD file loaded, you would have this KDD information. I'm not sure what that is now. That lists the VDatum. But if we did have, oh yeah, here's the little quotes over here. If there's a KTD file loaded up, it would fill that in with the KTD file name. And some other information like that is telling us that the GPS was being synchronized. Okay, and then if you look throughout the raw records, it's all time series data. So you have your position record with the device, the 0 right here coincides with the device number up here. DV, that's the GPS DLL. This is a time tag in seconds past midnight. We have our X and Y value in the POS record. I believe that's a course over ground or something. I can't remember what that value is. The quality record, QUA. We have the the device number, the time, the number of values following, and that's typically that value is not used right now, but that's a HDOP, that's the number of satellites, and there's that GPS mode I was talking about. The number 4 coincides with GPS, like a GGA string, and the NEMA standard. So the 4 is typically a fixed RTK value. And if you're doing your error stuff, it'll record the error X, Y, Z values in there too. The raw record is really important. This is the device number, again, the same, the time tag. The time tag goes throughout all these different values here. The number of values following, we have our latitude and longitude. It's the NEMA standard, which is decimal minutes times 100. Okay, so 32 degrees, 81 degrees west here. Our ellipsoid height coming from our GPS, and then our UTC time. And that's a really good one because that's the record that we use when we're recalculating RTK. We got that value coming in from the GPS. We can take those values, run it through our geodesy engine, and recalculate a new water level or even new positions if need be. So it's kind of a really useful string. And then this is the the tide value, the TID. If I'm using a tide gauge, it's going to write a tide value. If I'm doing RTK, it's going to calculate that tide value and by default use that tide value. KTC is a string that we've added for QC purposes also. And I probably have a description on another page here, but just basically all the values that are being used in order to calculate the RTK tides, the RTK water levels. And an MSG it'll actually write that raw, for example, the NEMA string coming from the GPS. With a posit V, we write the groups that come out of a posit V. They're binary, but we convert those over to an ASCII format, so it's a good way of troubleshooting the information. Okay, here's the KTC record, a description of all the values. So basically, you take, you got the KTC record right here with all the different values, along with the formulas in order to derive the proper tide value. Movement between RTK updates. There's a debate whether I should keep these slides in here, but this is all pertaining to mostly the single beam editor, but it's also in the multi-beam editor. Earlier in the days when we were doing RTK, all this stuff was making the assumption that you're using, well, first of all, GPS were only updating once a second for quite a number of years. And a lot of times if you had something that would update faster, there'd be a huge latency, 3 or 4 second latency, something crazy. So with one update, you're not going to get a good water level, especially in rough water. So you're pretty much making the assumption that you have a motion sensor. Okay, so if you're still using a GPS that's outputting a 1 second update, you should be using a motion sensor. Okay, you can basically use the RTK as a motion sensor if you're outputting 10, 20 hertz, or in the case of a pause, 50, 100, 200 hertz or so. And it's going to give you a pretty good idea. Basically you're going to use that value instead of using smoothing out the values for water level. But the idea of this was is basically taking is averaging those RTK values, those 1 second RTK values over a certain amount of time, say 30 seconds, 60 seconds or whatever, and it's basically just going to derive basically your water level. Okay, and then the motion, the heave compensator would take care of any actual movements. Okay, so you have a couple options in the editor. You would choose the RTK tide method, that's the average method. There's another one called merge tide data with heave, where basically using RTK in order to compute the normalized heave plane. And then the MRU, does that make sense? Being applied above normalized heave plane. But playing around with the values, there are variances. It appears, like from what I understand, that in really rough waters, the second method works a little bit better. The merge tide data with heave, but almost everybody uses the other option. You can also, if you want to, you realize you're having something going on with the heave and you're outputting the GPS at 10, 20 hertz, you can set this averaging period to 0, turn off the heave sensor, and then just use your RTK as basically a motion sensor. Okay. So just a couple examples here. Here's the average tide, where you get a water level here. And then here you have the merge tide data with heave, which just kind of reacts a little bit different there. You don't see much of a difference here with the two profiles. And yeah, just an example of using RTK without a heave. Again, you want to probably use at least a minimum of 10 hertz output or greater. So in order to set it up in HYPACK, you would uncheck the, or if you're not using the heave, you don't have to worry about it, but you could just uncheck that and either have set up like this, or if you leave everything checked, just turn off the heave device from your device listing and check the box here and enter 0. Basically do the same thing. In MBMax 64, you have a different option. You just check that box, and it's going to ignore the heave value and just use your RTK heights for the movements. So I think that covers pretty much everything there. Any questions?